Hi everyone, it's Mr. Baker here, and today we're going to be looking at density. So, density, why are some things lighter than others? Alright, first I'd like to do a little bit of revision on the phases of matter. So, look at these three objects here. What's the difference between the particles in these objects? I'm going to ask you to pause the video for a second and draw the difference between the particles in these objects. Okay, so pause it there. Okay, so we're going to have a look at what the difference is, see if your diagrams are the same as mine. So let's draw a diagram of a solid, a liquid and a gas, just as a bit of revision. So I'm going to draw three boxes. This is what I'll do. So solid, liquid, gas. So draw them nice and big, don't make the mistake of drawing them really tiny and having to draw millions of particles. So what I'm drawing is the particles, and they should be touching, and they should be the same size. So that's what a solid, that's good. So that's what a solid should look like. Liquid looks similar in that all the particles are still touching, or at least 50% of them should be really. Something like that, and then a gas. I might draw something like that. Okay, so in a solid, the particles are all close together. We've got this formation, and they're all touching each other, and they're just vibrating slightly around a fixed point. In a liquid, they're still touching other particles, so they can't be compressed still, just like solids can't be, but they've got a little bit more energy. Now the particles are free to move in between other particles, so they can move between particles, and that's what causes the gaps to appear in between as they're sort of flowing between each other. And in a gas, they're not touching, and I always draw one particle just sort of whizzing out of the box. So imagine these are three particles whizzing around, and one of these particles just going out of the box. Okay, so if you looked at the kinetic theory, which one's got the most energy? The solid particles are vibrating around a fixed point. They've got the least amount of kinetic energy. They're moving the least quickly. The liquid particles are moving a little bit quicker. They've got a little bit more kinetic energy, and they're moving around freer. And the gas particles have got the most kinetic energy. They're moving around with the largest speed. So that was a bit of revision. So obviously the solid was the brick, the liquid was the water, and the gas was what's inside the balloon. Let's have a look at another example. So this is something you can try at home if you've got some different cans of Coke. So what will happen if you put normal Coke in water, it will actually sink down into the water, whereas Diet Coke will actually float. And this helps us to explain, the explanation of this helps us to describe what density is. So think about why you think that might be. If I tell you that density is the mass per unit volume of a material, and because of that then its units are going to be kilograms per meter cubed. So here, why does one can float and the other one doesn't? Again, I'd like you to pause it, see if you can draw a diagram of it, and then you can have a look at my diagram and see what the explanation is. Okay, so pause it there. Okay, let's have a look then at what the explanation is and see if your diagram looks anything like mine. So, as you might have guessed, the answer lies in the sugar content. Normal Coke has sugar in it, which makes it denser than water, whilst Diet Coke has no sugar in it, and so it's lighter per unit volume than the water, and therefore it floats. Have a go, see if you can get it to work, and I'll show you the explanation. Okay, so you've seen the picture of the full fat Coke and the Diet Coke floating and sinking. So this is the Diet Coke and this is the normal Coke. So that's Diet and that's the full fat Coke. But what I want you to think about is why that is and what are the particles like in each of those things. So if we have a look, just to start off with water, what water looks like. Okay, so I'm going to draw the particles in water. So the particles in water are touching each other, they're a liquid, but there are some gaps in there, so it's not the same as a solid. Okay, so they might look something like that. So there are some gaps, but there's no structure, the particles are moving in and out of each other. Now there's a difference between these, so if we look at why this one floats and this one doesn't, and it's to do with the density, and it's actually to do with the amount of sugar. So normal Coke has got sugar, Diet Coke hasn't got sugar, and so because of that, the Diet Coke is less dense than the water, and the normal Coke is more dense than the water. So there's more particles for the same amount of volume of water in the Coke than there are in the Diet. There's less particles for the same volume as normal water, and so that's why the Diet Coke floats and the normal Coke sinks. So if I was to draw what's going on inside here, so this is like my zoomed in like microscope. So normal Coke. So the same kind of diagram as for the water. Okay, so there are some spaces between, but actually there aren't any spaces in between, because although Coke is mostly water, there's an awful lot of sugar, and there are all these little sugar particles that kind of make up the difference in the gaps. And so now there are more particles in the same volume than there are in normal water. And in Diet Coke, let's zoom in on this one as well. So Diet Coke is just a little bit more spread out, so the particles are still touching. I'll try and draw that in a minute. But there are more larger gaps. So here you can see there's all this space in between the particles, and although these particles are still touching, they're still a liquid, there's more gaps in between here than there are in here, in the water. So this is our Diet. This is our normal Coke, and this is water. So the full fat Coke sinks in the water because it's denser than the normal water. The Diet Coke floats because it's less dense, it's got less particles in the same volume, and this has got more particles in the same volume. Okay, so we've kind of described what density is, had a look at some different examples of some different objects' densities. This is our definition of density. Density is the mass per unit volume of a material. So if you had two objects that have got the same mass, so you've got these two objects here, which one of them would be the densest? They've got the same mass, but which one would be the densest just looking at them? Okay, well hopefully you said that object A would be the densest because it's got the same mass but it's got a smaller volume, so there must be more particles, more stuff in here than in here, so it's got to be denser. Okay, so if you now had a ruler, how would you find the volume of these boxes? So how would we find how much space within each of these boxes? Okay, so if you had a ruler, to find the volume of a regular shaped object, so something like this, like a cube or something like that, then what you would do is you would measure the length, the width and the height, and then you'd multiply those three things together, and then you'd be able to find the volume. And so if you knew those two things, if you knew the mass and you knew the volume, then we've said that the density is the amount of stuff in a certain amount of volume. And so we can describe the density. We're using this symbol here. It's like a P. It's a curly P. It's actually a Greek letter rho. But you just need to know the symbol for that. So density equals the mass, and our symbol for mass is m, divided by the volume, and our symbol for that is v. So density equals mass divided by volume. and you need to be able to do some calculations with this. So our definition of density is mass divided by volume. So you could potentially use a triangle or just learn how to rearrange these equations here. So density, rho, if I wanted to find what that is, I put my finger over that if I was using a triangle, and that'd be the mass divided by the volume. Mass equals density times volume. Volume equals mass divided by density. And you can measure density in different things. Normally we use kilograms per meter cubed, but as long as you are consistent with the units, then you can probably measure it in different things. So you could use grams instead of kilograms, centimeters cubed instead of meters cubed, and then you'd have grams per centimeters cubed, because we normally measure mass in grams or kilograms. We should really measure it in kilograms, but depending on the question, you might decide actually grams is a bit easier. Volume, again, we normally measure it in meters cubed, but you might decide actually for this question centimeters cubed is easier. The only thing is, depending on what the question asks you for, you might have to convert from grams into kilograms or centimeters cubed into meters cubed. And so if you had to do that, there are 1,000 grams in a kilogram. 1 milliliter is the same as 1 centimeter cubed. If you ever get volumes in milliliters, then so if you're looking at volumes of liquids, then you might have milliliters, and that's the same as 1 centimeter cubed. 1 liter equals 1,000 milliliters, and so then if 1 milliliter equals 1 centimeter cubed, then that's going to be 1,000 milliliters is going to be 1,000 centimeters cubed. And there are 100 times 100 times 100 centimeters in a meter cubed. So 100 times 100 times 100 is a million. So there's a million centimeters cubed in a meter cubed. So beware of that one. Just make sure that you are converting the units correctly for that one. That's a common mistake, to convert those units wrong. And if a question asks for a specific unit, for example kilograms per meter cubed, then that's what you've got to do. If it doesn't, then just be consistent with the units that they've used in the question. If they've used centimeters cubed and they've used grams, then that's what you should put your answer in. But if they've asked you to do it in kilograms per meter cubed, then that's what you've got to do. You've got to convert some of these units into those. Okay, so that's this lesson done for density. So these are the things you should be able to do. You should be able to describe what density is in terms of the particle model. You should be able to explain why some objects float and be able to calculate volume and density. You should be able to convert units from grams to kilograms and litres to centimetres cubed, and to use the density equation and rearrange it as well. So you'll probably need to have a little bit of practice on all of those things, but for now, this is Mr. Baker finished.